Hello everybody, Root Beer here. Thank you for joining me once again as we continue on our look at the 2012 MMC Manitoba Math Contest. We're up to question number 8, so let's have a crack at that one. Question 8. A line with positive slope, so if we're thinking things like y equals mx plus b, the m will be positive, passes through the origin, okay, so that actually tells us what the b would be if we were doing y equals mx plus b, and is tangent to the circle x minus 5 squared plus y squared equals 9. Find the equation of this line. Okay, so it's tangent to the circle, and for anyone who's done things like some more advanced stuff like calculus, if you've taken some calculus, you might think, tangent to a curve. I should be thinking derivatives. No. These questions, just like the MMC and its fellow contest, the Euclid, Open, these things are meant to be done without the use of calculus for the most part. Calculus is more of a university technique, at least when it comes to math contests. And we're going to be able to do this without any calculus. So put away your derivatives. We're going to be using circle geometry, which isn't exactly gone over a whole lot for the most part in North America, but is still useful, especially on contests. Okay, so the first thing we want to do is get an idea of what's going on. Where's this circle? Where's this line? What sort of picture am I drawing? Okay, so our equation for the circle, x minus 5 all squared plus y squared, is equal to 9. Well, 9 is 3 squared. I'm going to get a radius of 3. And I can also pick off, this is y minus 0 and minus 5. We can get this, sorry, not minus 5, just 5. Because it's x minus h squared plus y minus k squared, and the h and the k gives us the center. And then the r squared gives us the radius. So if we were to draw ourselves a picture, we have 5, 0. That's our origin here. Radius of 3 means we're going to have 2, 0 over here. We're going to have 5, 3 up here. 5, negative 3 down here. And 8, 0 all the way over here. And let's try to draw a circle. Well, that's not the worst circle I've drawn, so I'm happy with it. It's going to work for my purposes. So there's our circle. And then we've got the line. And the line passes through, let's use, say, orange. The line passes through the origin. And then to be tangent, he needs to sort of hit just once. We don't quite know where that point of tangency is, and then move off. He's going to have a form of y equals mx. So we might even make a note of that, because that's important. A line has equation y equals mx. And they were telling us that x is positive. So we get no y-intercept, because the y-intercept is at 0, 0. Okay? And this is actually pretty nice, because what does it tell us? Well, we don't know the point of tangency. It's at some point. But we know since it's on the line, it's got to look like this. So it's at some point of the form x mx. Okay. Now, whenever I think circles and points of tangency, the almost first thing I do, I don't want to say the first because I got a lot of videos and I might do other things, but in general, the first thing I do is I connect the radius. Now, we know the radius is 3, but we connect the radius from the center of the circle to the point of tangency. And the nice thing about tangency is we get a right angle there. We get ourselves a right angle. And, well, what have we got here? We've got a right-angled triangle. So the origin, the center, and point of tangency form and we'll put it in a color, form a right triangle. This right triangle right here. We've got 3 on the one side, 5 on the other, distance from the center to the origin. This is a 3, 4, 5 triangle. Not bad. Okay. So we might specifically say a 3, 4, 5 triangle. And we might explain that a little more. You might want to Pythagoras that out. You know, where does the 5 come from? Well, 5 squared and then minus the 3 squared. You do get a 4 squared here. So the distance from xmx to the origin is going to be 4. All right. So what can we do with that? Okay. Well, one thing we can do is we could make yet another right-angled triangle. So x is this distance here. mx happens to be this height. So you could say by Pythagoras, you could also say, if you know the distance formula, the distance between 0, 0 and xmx, no matter what you want to do, but you could say by Pythagoras, 4 squared is x squared plus mx squared. Well, that's x squared plus m squared x squared. So we could get a 1 plus m squared out of there. And we get an x squared there. Okay. So it's not looking so bad. 4 squared is 1 plus m squared x squared. Okay. So what else could we do? What is it that we want? What is it that we want? We'll find the equation of the line. Okay. So this, if I don't know what x is, this isn't quite enough to solve everything. But we know one other thing. Not only is x mx obviously on the line y equals mx, it's also on our circle equation. So we haven't used this piece of information. So since it's on the circle, what could we do? Well, we could say it plugs in, so x minus 5 all squared plus, well, what's y? Well, it's mx squared is equal to 9. We can clean this up a little bit. X squared minus minus 10x plus 25 plus m squared x squared is equal to 9. Well, hey, look at that. We know that that's 4 squared, which is 16. So 16 minus 10x plus 25 is equal to 9. Okay. So we can bring a lot of this over to the other side. We get minus 10x is equal to 9 minus 16 minus 25. 9 minus 16, that's negative 7, minus another 25, that's negative 32. So x is negative 32 over negative 10. Or we could say it's 16 over 5. And that's about as clean as we can make that. And now we could plug that back in and solve for m. Okay. So we don't quite have the room to do that. I'm just going to mosey on over to the next page. So we know 16 is 1 plus m squared. X squared, well, that's 1 plus m squared 16 over 5, all squared. So that's 1 plus m squared, and we'll get 256 on top, 25 on the bottom. multiply through by 25. 16 times 25, that's going to be 400. So 400 is 1 plus m squared times 256, but I can divide by 256 over here. Heck, we could have avoided a lot of this and divide by top and bottom by 16. 25 over 16 is 1 plus m squared. Subtract 1 from both sides, and get 9 over 16 is m squared. Square root, we get 3 over 4, or negative 3 over 4, but we don't count this one because m is positive. Okay, m is 3 over 4. All right, so that's all we needed. M is 3 over 4, so line has equation y equals 3 over 4x. And that's all we wanted, the equation of the line. There we go. Should technically say find an equation of the line since they didn't ask for y-intercept form. Now, something I left some space here because I just thought of something as I was working on this. So we know we get this right angle triangle here. Excuse the diagram isn't quite as good as it was on the other page. That's not really the point. If you have line y equals mx, if you know this angle in here, theta, there's a nice little relationship between m and theta in that m is the tangent of theta. This is something that, frankly, I think I just picked up somewhere along the way. But it comes from sort of triangles here. So if we had one here, if one is what is tangent? Tangent's opposite over adjacent. So if we go over a distance 1, and what's our rise there? It's going to be tangent of theta. What's the slope? Rise over run, so tan theta over 1. So this is pretty nifty because what have we got? We've got an angle in a right angle triangle here. So what's this angle theta? Why, it's going to be opposite over adjacent, 3 over 4. And if you made that connection, as long as you explain it a little bit, you would have been able to get the question even quicker. You wouldn't have had to mess about with any calculations. So I think that's the slick way. I'm a little disappointed in myself I didn't see it the first time, but I did sort of see it as I was going through and working out the calculations. So there's 2 different ways to do the question. Both of them are perfectly fine. We didn't really struggle a lot with either one. I'm just kicking myself that after all these years I didn't see the tangent way of doing it. And, maybe out there you guys did. And that's great. If you didn't, that's okay. Now you got 2 ways to do it. So that was what, question 8? Yeah, question number 8. So we got 2 more to go. Question 9 in the next video and 10 after that. Thanks for watching, and I'll join you guys for the next video in a bit. I'll start recording that right away. So long for now.